two different figures having same volume, whose surface area is minimum. Let us check. Cube of side x whose volume is x cube. Let us take it as 8 pi cube. X will be 2 pi. Surface area will be 6x square. X square is pi square value is roughly 10. So 240 meters square is the surface. If you take a sphere whose volume is 4/3 pi r cube, which is 8 pi cube, pi square. So roughly r cube is 80, 420 is 60. Approximately r is 4 point something. Let us take 4. Surface area is 4 pi r square. R square is 16. 64 into 3, roughly 192 point something. So it's a large gap. It very clearly indicates sphere has least surface area for given volume. But why he included this question in physics? We have a concept of surface tension. So because of surface tension, water drop tries to occupy minimum surface. More surface area, more surface energy, unstable. Less surface, less potential energy, more stable. So for stability, it takes spherical shape. In that process, due to surface tension, that surface has least surface area, which is possible with the sphere. Which of the following can produce maximum induced EMF? Induced EMF here is minus L di by dt. For a direct current, di means change in I, which is 0. So in first and third options, induced EMF I first and third, induced EMF is 0. But he says maximum. Maximum current is same. It depends upon frequency. We have a related to magnetic field and frequency. We have a relation. The rate of change of magnetic field is proportional to frequency of alternating current. So as frequency is more, alternating magnetic field will be more. Your 400 Hz, 6 amperes, 400 Hz. So in that case, it produces maximum EMF, maximum induced EMF. You have two forces, 5 dyne and 6 dyne are acting. The resultant is, we don't know at what angle those forces are applied. Resultant force, we have a formula. Based on that, boundaries will be P minus Q and P plus Q. The resultant force can be in between 1 and 11 dynes. Here, a chain of mass M and length L held vertical, by fixing its upper end to a rigid support. Here, in this case, suppose string is massless, tension is same at all points. But here he considered a chain uh, which is held vertical by fixing its upper end to a rigid support. Then what is the tension? In chain at a distance y from the rigid support. Rigid support is here. So at a distance y. So total distance is L. So this remaining distance will be L. In this, since it's a chain at each end point, mass differs. So for L unit length, mass is this. For 1 unit length, M by L. For L minus Y units, mass will be M by L into L minus Y. Tension at P will be M by L into L minus Y into G. Thrice as much as time to slide down 45 degrees rough inclined plane as it takes to slide down from a smooth. Here we have two cases. One is smooth surface, other is rough surface. Rough surface obviously takes more time. Assume that block is here, it has to travel L length. So the only force act on it is mg sin theta when angle of inclination. So here force is mg sin theta. A becomes g sin theta. When it starts from rest, it has to travel L length, u0 half L half g sin theta t square. T1 here is 2L by T1 square. In this case, when it's a rough surface, force acting on is as usual force component of gravitational force. There is a frictional force that is mu mg cos theta. The acceleration becomes g into sin theta minus mu cos theta. G by root 2 into 1 minus g2 square will be 2L by here s equal to half gt square, that is 2L by g into 1 minus mu by root 2. Here it is T2 is 3T1, T2 square is 9T1 square, 2L root 2 by g into 1 minus u. Here it is 2 root 2L by theta is 45 degrees. 2 root 2L by G. 2 root 2L. Here it is 9 times. G get cancelled. So here 1 minus mu is this. Mu will be 1 minus 1 by 9. So 8 by 9 is the answer. Here two wires of same material. Young's modulus is same. L is same. Cross-sectional area are in the ratio 1:2. Same load is applied. Here it is having different cross-sectional area. applied force is same. Young's modulus is stress by strain. Strain is change in length by original length. Y same, F same, L same, which implies A into delta L is constant. That means ratio of their extensions are inversely proportional to areas. Delta L1 is to delta L2 will be 1 by A1 is to A2, which is A2 is to A1. So he given cross-sectional area are in the ratio 1 is to 2. Extensions will be are in the ratio 2 is to 1. Here a body floats in a water with 1/3 of its volume is above the surface. 1/3 is above the surface. 2/3 will be, let us say total height is h. 2/3 will be within the water. So upthrust here is, that is force of buoyancy is VdG. So cross-sectional area is A, and 2/3 part is in water, and density into G. If it is placed in some other liquid, that is oil, it floats with half of its volume over the oil surface. So the case 2, if it is placed in oil, let us say let D1 be density of oil, then here this is what weight is equal to upthrust. Here weight will not change, but upthrust area into, we don't know, here he given half of its volume means area into h by 2. Cross-sectional area is A, and height is h by 2, part is in oil, density is D1. So from 1 and 2, A into h by 3 dg is equal to A into h by 2 d1 into g. H get cancel, g get cancel, area get cancel. So d1 will be how much? 4d by 3. d1 by d here is 4 by 3. Specific gravity of oil means that we will compare with density of water, that is 4 by 3 stands. On tripling the speed, the stopping distance for same braking force. Here, body is moving with u velocity, some force is applied, let us say braking force, then it comes to rest. V square minus u square is 2s. V0, so let us say body of mass m, then force will be this. A here is F by m into s. It's retarding, so we will have u square is 2f by m. Another body is moving with 3 units of speed, but same force is applied on same mass, acceleration will be same, but stopping distance will be different. Say it is 1, so 1 you divide with 2, you get 1 by 9 is this. So S1 becomes, stopping distance becomes 9 times. Here a circular ring of mass m and radius r is floating, rotating about an axis through the center. Normal to its plane with a constant angular velocity omega. Two objects each of mass m attached gently. This is very important. So attaching gently means no external torque. No external torque means tau is zero, dl by dt is zero, angular momentum is constant. I1 omega 1 is I2 omega 2. Since it is a ring about an axis which passing through the center, it is mr square omega 1, he given but omega 1 as omega. I2 will be now gently two masses are added at the opposite ends of a diameter. That means it is at r units distance, m r square plus 2m r square of omega 2. So omega 2 is mr square omega by r square into m plus 2m r square. Get cancelled. M omega by m plus 2m. A body has an equal amount of rotational kinetic energy and translational kinetic energy while rolling without slipping. First thing, rotational kinetic energy is half I omega square. Translation kinetic energy half mv square. Rolling without slipping, v is r omega. Then translation kinetic energy will be half m r square omega square. So then he given that rotational kinetic energy is the translation kinetic energy. So I becomes mr square. So it's nothing but a ring. Here if the current through an inductor of 2 henries is given, then voltage induced is minus L di by dt minus di by dt. Here I is a function of t, just differentiating t cos t plus sin t. L here is 2 henries, so which is 2 times t cos t plus sin t. Two bodies of masses 1 kg, 2 kg have position vectors. Position vector of center of mass is r bar equal to m1 r1 bar plus m2 r2 bar by m1 plus m2. Here m1 is 1 into I plus 3j plus k. M2 is 2 times minus 2i plus j plus k by 3. Minus 4i plus 5j plus 3k by 3. M1 R1 plus it is minus 3i. Minus 3i plus 5j k plus 2k, 3k. Here it is 2k, sorry, 4k. Then you'll have 5k. So second option is correct. Here gravitational field intensity, uniform solid sphere. So at a distance r, that is this is capital R. At this point, he is asking gravitational field intensity Gravitational field intensity is nothing but force experienced by unit mass, that is gm by r square by m. So gravitational field intensity will be gm by r square. But here it is m is mass of solid sphere, but you want at this point, so not m dash, which is mass of this another small sphere which is inside, mass of sphere inside bigger one. For r radius, its volume is 4 by 3 pi r cube, its mass is, for 1 unit radius, m by 4 by pi r cube. But small r radius, what is the mass? M 4 pi by 3 r cube by m 4 pi by 3 capital R cube. So which is r cube by r cube. So gravitational field intensity will be gm dash by r square. So gm dash is which is r cube in terms of capital M. M dash will be mr cube by capital R cube into r square, which is gmr by r cube. Third option is correct. Two springs, here it is. Under critical condition, velocity at v naught, under critical condition at this point, say at b, velocity will be root 5 gr, if r is the radius of this circle. But to find critical velocity at p, which is at a height h, so by applying conservation of energy of mub square, here taking this as a referral line, its potential energy at b is 0, it has only kinetic energy. At p, it has some kinetic energy and potential energy. So this h will be r plus h1. It is r, it is h1. This angle is 60, it will be 30. For sine 30 will be h by r, h1 by r. H1 will be r by 2. So height will be 3r by 2. So now if you consider this half, say this equation, at for critical velocity at b, velocity will be 5gr, half mv naught square plus mg into 3r by 2. Half mv naught square is 2mgr by 2. So we get here v naught square as 2gr. V naught will be root 2gr. Third option is correct. There are two springs having spring constants K1 and K2 are stretched by same elongation, then work done. Work done in stretching x distance is half kx square. So for the first spring, work done is half k1 x1 square. But here x1 in the sense, which is x, let us say, he given same elongation for second spring, W2 is equal to half K2 x squared. So here, since extensions are equal, it only depends upon spring constant. He given K2 is greater than K1, which implies W2 is greater than W1. So the work done will be greater for K2.